In Python, we can define our own new types of objects, and we do so using a class. In a previous video, we talked about the concept of an object, and we said that, for example, every string is an object, and that objects have attributes, which are the data values that are inside them. You can think of those as variables that belong to the object, and methods, which are functions that exist inside the object. And it turns out that everything in Python is an object, including data types like integers and floats. Every data value that you have in Python is an object. Closely related to the idea of an object is the concept of a class. And you can think of a class as a blueprint, a definition of a data type, or a definition of a type of object. And this is where we actually specify the attributes and the methods of that type of object. And then objects are built according to the blueprint provided by their class. And they are sometimes referred to as instances of that class. Now it turns out we can use the type function to figure out the class of an object. So for example, if we pass in an integer to the type function, we'll get back the class int. If we pass in a float, we'll see that it's of the class float. And this is the name of the class that this object is built from. It's the type of object that that number is. If we use a string as the input to type, we'll get back the class str. If we pass in a list, we'll get back the class list. Now what's great about Python and other object-oriented languages is we're able to define our own classes, which means we're essentially able to create our own data types. For example, let's say you're working on a program in which you're using a lot of rectangular shapes. Maybe you're doing a drawing of some sort or a graphical user interface. So you might want to have objects that represent rectangles. And inside each rectangle object, you could put attributes for the width and the height of the rectangle. You might also want, if you're using it for drawing, to have coordinates of the upper left-hand corner. And then you might also want to give it methods for things like computing the area, computing the perimeter, growing the rectangle, moving it on the screen, etc. And so this would be an example of a data type that you might want to create. And to do that, we're going to define a class. So here's an initial rectangle class. We're starting with a class header. So you have the keyword class, and then you pick the name that you want. Then you have a colon. And then we indent, just like any other block of code. We typically want to have a docstring, just like we use docstrings for functions. And then we have a special function, a special method, known as the constructor. The name has to be underscore underscore init underscore underscore. And it's used when we create new objects. It's also how we specify the attributes that belong to objects of this class. And the way to do that is to make use of this special parameter self, and you can think of that as a reference to the object that's being created, and we're going to use that reference to assign things to variables that are inside the object. So self.x, self.y, self.width, self.height, and by assigning things to those variables, we're creating the attributes. We're saying every object will have those 4 attributes inside it. And you can see we're initializing x and y to 0. For width and height, we're assigning whatever gets passed in from these other parameters. And we can see that if we look at a concrete example of calling it. Now it turns out when we call it, we don't say underscore underscore init underscore underscore. We instead use the name of the class. In this case, we're creating an instance of the rectangle class, and so we use capital R rectangle. And then we have to specify parameters for everything but self. We don't actually specify a parameter for self, but we do have to specify a value for any other parameters of the constructor. So in this case, 100 is getting passed in and assigned to init width, and 50 to init height. And so after the constructor is done, we will end up with this rectangle object. X and Y are both 0 because that's what we always start out with for X and Y. Width is 100, height is 50. And what the constructor gives us back is a reference to the object that was created, and we are storing that, in this case, in the variable r1. So r1 doesn't contain the object, it contains a reference to the object. If I need a second rectangle object, I can just use the constructor again. In this case, I'm giving it different dimensions, and so I end up with different values for those attributes. And in this case, the object's reference is being stored in the variable r2. Once I have a reference to a rectangle object, I can go ahead and access its internals using dot notation. So for this particular rectangle object, the one that I created using dimensions of 150, if I were to say r1.width, it's telling Python to look inside the rectangle referred to by r1 and to give me the value in the width attribute. And so what I'll get back here is 100. If I want the height, I can do r1.height, etc. I can also change what's inside the internals by using an assignment statement. So for example, currently the x is 0, but if I say r1.x is assigned 25, then what's going to happen is, after the assignment, x will have 25 in it. And so I've changed that attribute in r1. I could also do something to the y attribute, assigning it 10, and I can even do something like this, where I'm basing the new value of the width on the current value using the shortcut times equals operator. So just like you would modify any other variable, you can modify the attributes in an object.